चाहे मेरी जान जाए चाहे मेरा दिल
Good morning, everyone. I hope my voice is audible. Anyone?
Yes, it is
Yes,
audible.
sir, audible.
All right. Right. So I welcome you all to the first class of geology optional new batch. Right. So today, like we will have, we'll start off with general geology, and before that, we will have a slight overview of geology and also some previous questions, analysis of general geology. Right. Hello.
Hey, hello. Yeah, Mayank sir, your screen is not visible.
Okay. So I hope my screen is visible to you all, right? All right. So again, a very good morning to everyone, right? So like today is our the first class of our new batch of geology optional
Mayank
comprehensive.
sir, I just want to ask.
Yes.
So the screen is not visible to me. I just want to confirm with others. Can others see the screen?
Yes, sir.
Okay.
Yes.
Yes, sir.
Okay. I don't know. Like, yeah, maybe something issue with from my side. Okay. Yes, Mayank
Okay.
sir, you can continue.
All right. All right. And there we discussed what are the advantages of geology optional, right? We also discussed the syllabus, right? And we also discussed the trends in marks in civil services as well as in forest services which are there in geology optional, right? So now today we will directly start off with geology, right? So today's session is essentially so I hope you were able to see the video, right? So it was just an overview of geology to a in a very layman language, right? So like you saw what is geology. So in that video, the guy used various keywords, right? So they tried to define the domain of geology. So like they were like features on Earth, right? Landforms, landscape. This was the term they used, right? They used geology is about ancient life, right? They use this term ancient life forms on the Earth. That is geology's study of fossils, right? Like today on the planet Earth, the most dominating species are humans, right? Along with humans, there is tiger, there is lion, right? There are sparrows, and there is a lot of wildlife over here. So similarly, in the ancient times, there were some other species, right? You must have heard about dinosaurs. Now, before them, there were some cockroach-like species like trilobites and a lot others. So geology is study of life forms, how they evolved, right? So it is also one of the aspect of geology, right? Another thing in that video they talked about maybe floods, right? They talked about hazards. So geology is also about studying of these natural hazards, right? So in general geology, we will study something about earthquakes. What are earthquakes? How they are caused, right? Is there a way to predict earthquakes? All these things. We will also discuss about volcanoes, right? So these are all core domain of geology. Apart from this, in that video, they were all also talking about resources, right? So geology is also about resources like coal, oil, right? In fact, every resource, every metal, non-metal which is mined, you can think of is related to geology, right? So basically uh, these were about domain. So basically the word geology, it means geo means earth, right? So geology is about study of earth, right? Somebody's, I think this microphone is on, so please, like it is creating a bit a disturbance, right? So all right, so like this is geology. Geology is study of earth, right? So like what is study of what you will study in earth, right? So firstly you will start off, if suppose you are a tutor, you are a professor, and you have to frame a syllabus of this study of earth. What will you frame, right? So logically, first the first thing which you will frame in the syllabus is how earth originate, right? Origin of earth, or you can say Earth is part of solar system or the universe. So you should know something about origin of universe. So this is our unit 1 of our syllabus. Here we will study about origin of Earth. Right now, what are the features? What are the processes which happens on planet Earth? Right. So there are a lot of events like earthquake, volcanoes. Right. All these things happen on Earth. So we study about them. This is also part 1 of our syllabus, unit 1 of our syllabus. Right now, right. So after that, what else do we study? Now we know how Earth originated, what we saw on Earth, right? Then we can see what are the landforms on the Earth, right? There are mountains, there are rivers, right? Rivers form deltas, right? Then there are beaches formed by sea, right, or the ocean, right? Then there are dunes which we get in desert, right? So geology study all these landforms present on the Earth, right, within the study of Earth. फिर उसके अलावा the another thing is which is very important is geology study structures, right? When you study Earth, you will study structures, right? There is mountain, right? So mountain looks like something like this. The mountain is essentially rocks, right? So these are some features. This is technically called something, this is technically called something. So we are studying various structures, right? We will study about faulting, right? We will study about fractures, all these things. So this is the domain of Earth. Then another way of defining geology is apart from study of Earth is geology is study of rocks, right? So geology is study of rocks, and we all know that from our school study, there are 3 kinds of rocks, right? The first type of rock is igneous rock. These are the rocks which are formed by volcanic processes, right? Whenever a volcano erupts, it is very hot. When it cools down, it becomes solid and it forms various igneous rocks, right? Then the second is sedimentary rocks, right? So like whenever there is some rock, with time there is weathering, right? There is erosion of all these rocks, so they will become sediments, and after some time they will again accumulate, right? And they will get solidified, so they form sedimentary rocks, right? Similarly, there are some other rocks, we call them metamorphic rocks. So we'll study all of them, right? So this is why these are basically the domain of geology, right? And like one last thing which I want to tell you, like, can anybody tell me why we should study rocks? Why we should study rocks? Like, rocks can give us a lots of information, right? But tell me few reasons about why we should study rocks. Anyone? Okay, so Kaushal is saying it is about it lets us to know about resources, right? And Tranayam is saying that information about evolution of Earth, right? And Sudipta is saying it tells us about the age of rock, right? So these rocks can help us to determine the age of rocks, like Sudipta was saying. She was saying rocks ultimately weathers and they form soil, and soil is backbone of agriculture economy, right? Or our survival, right? Then similarly, Ashwarya is saying again she was saying about soil. Uttam is saying that rocks are those in which fossils are formed, right? And if we are able to study rocks, we will be able to study fossils, right? So if we will be able to study fossils, then what will happen? We will be knowing how life evolved, right? What all creatures lived on planet, right? So Uttam was saying that it helps us to know about fossil. It helps us to study soil, right? Then all these things, landforms, paleo environment, right? One of the another very important is about resources. right? Somebody mentioned that also, right? So like tell me, what are the most important resources? What are the most important resources for human civilization, right? Can anybody? One of the most important resources for civilization, Kaushal is saying iron, right? So all metals, right? All metals. This mining is backbone of modern human civilization. Before that, I think water. This is the most important resource, right? What are other important resources? Oil, right? We are so much dependent on oil, gas, right? Coal. We are sitting here in an online class using electricity, and most of the electricity in our country is made from coal, right? We are driving daily to our schools and colleges and offices, right, using vehicles, and all the vehicles in our country presently are driven by oil, right, petrol or diesel, right? Our survival. So these are all. Coal is basically a rock. Coal itself is a sedimentary rock, right? This oil, where is this oil formed, right? Where is this oil formed? This is surface earth. Oil is found somewhere deep inside earth and trapped in pores of some rocks, right? There are some rocks, they have some pores, and these oil and gas, these are trapped in these pores only. So basically, if we study rocks, we study the characteristics of rocks, we will be able to study oil, and we will be able to extract them. Similarly, water, you all use water. No, we have groundwater, we have bore wells in our houses, right? So what is bore well, right? From where does the water come? Water comes from rocks itself. There are some rocks inside the earth, maybe 30 meter, maybe 300, or maybe 200-meter deep, something like that. So and these pores in the rocks, they have water, and technically we call them aquifers, right? So like we have a subject called in paper 1, unit 6, it is known as hydrogeology. Hydro means water, and this is geology. So this chapter essentially is about groundwater, right? Ki how groundwater flows, how, what is the chemistry of groundwater, what is rainwater harvesting, right? Then there is a law known as Dorsey law, which says that groundwater flows just like river flows. Groundwater also flows under the effect of gravity or gradient, right? So there is a law which determines the rate of flow and all these things. So this is a very important part, right? Somebody says that about iron, right? Trinayan says about iron. So today modern civilization is based on mining, right? Like you wake up in the morning, and the first thing you do is you use toothpaste, right? Which has a fluoride in it, and some other elements in it, right? You use fan, you use vehicle to drive, maybe public vehicle or your personal vehicle. It is all made of steel, right? And other you use battery, which is made up of lithium, and a lot of other rare earth elements, right? So whole our life revolves around, in a way, around metals or non-metals, right? And all these are extracted from process which is known as mining. And in mining, what do we do? In mining, what do we do? Ultimately, we extract rock only. Rock. So economically, our modern civilization is based on rocks itself, right? Extraction and knowledge of rock itself. Whole our industries, our economy, our life, they depend on rock. So that is why we need to study rocks from economic point of view. From scientific point of view, like Uttam was saying, studying rock, we can we are able to determine the age of various features of rock. We are able to study fossils and all these things, right? So that is the commercial as well as academic significance of geology, right? So that is the thing. So this is just a overview, like what are the domains and all these things about geology, right? Now, since we are just beginning the course, one thing I want to tell you that what is our objective of this course, right? What is our objective? What is our aim for this course of geology optional, right? Our primary objective is to maximize our score. right? To maximize our score in IFS and CSE, right? We should target 300 plus in both the examination, and this like we'll do using the best quality content and other resources, right? And another objective is our objective should be that we don't want to be like, we are all here for a purpose, right? That is to clear the exam with highest marks. So we don't want to be professional geologist, right? We don't want to be professional geologist, or neither we want to do PhD in geology, right? So our focus has to be on syllabus. Whatever is given by UPSC in the syllabus, we will cover each and every topic of it in the course, right? Syllabus plus previous year questions, right? Because it is also a fact that about 80 to 90% questions are repeated every year from previous year questions, right? So these are the two things we should always keep in mind. We don't want to do PhD on geology, so it will keep us focused, and we will go in sufficient depth, but we won't overdo it, right? So that we should always remember. So okay, this is it. So I hope you understand what is geology. Geology is about study of rocks and study of earth, right? In earth we discussed about all these dimensions, right? And in rocks we now know the importance of rocks, right? For industry and for in general academic purposes, right? So these are some very basic things about rocks. Now just I want to show you, I hope you all have the geology syllabus, right? So like, since we are preparing for a competitive examination, it is very important that we mug up the syllabus. And this is not important only for optional but also for GS, right? So it is very important for even for general studies, you mug up the syllabus. You should remember syllabus word by word, right? So like, even for general studies, if suppose you are reading newspaper and there is a keyword maybe civil society in your syllabus, somewhere this term civil society is mentioned. This is mentioned in paper 2, I think, right? So suppose you are reading any magazine, you are reading newspaper, or you are hearing news, and you heard about this term civil society, maybe NGO or even pressure group, right? So you should know that okay, this is something related to my syllabus and I should pay for attention on it, right? So similar is the case with geology optional, right? So the one thing with geology is that almost 99% of geology is static, right? So it is not current affair driven. So that is a good thing. But if whenever you are reading any book, maybe even newspaper or anything, and if you are able to remember the syllabus, it will help you a lot, right? Plus remembering syllabus is another advantage, and that is it will help you interlink, right? So suppose you remember that island arc, trenches, mid-oceanic ridges, these are part of paper like general geology, right? Or maybe interior of the earth and all these things, these are part of general geology. And you also mug up igneous geology, right? This is part paper 2. This is 8th unit of the syllabus. So if you are able, if you remember them well, you can interlink them, right? This we'll learn gradually as we progress, right? So this is the thing, and this is general syllabus. This I have shared on the portal, right? On the course, right? So you can find that there also, and it is also there in the UPSC notification. So this is complete syllabus. This is syllabus for civil services as well as Indian forest services, right? So the syllabus for Indian civil services and forest services is same, right? 95% it is same. Just that whatever I have done it in red color, this is explicitly mentioned in IFS syllabus, right? So like, suppose today we are starting general geology. So this is the syllabus of civil services, right? And this full is the syllabus of IFS, right? So IFS has these 6-7 bullet point, plus they have these 3 things mentioned additionally, right? But this does not mean that these 3 are not part of civil services syllabus. Right? Like, in civil services they have mentioned about age of earth, but they have not mentioned radioactivity. So when you will study age of earth, one of the way to, or one of the most important way to determine age of Earth and age of various features of Earth is through radioactive methods. So ultimately, radioactivity is part of civil services syllabus also, right? But they happen not to mention it directly in the syllabus. Similarly, orogeny and apyrogeny, when you are reading about plate tectonics, these are inherently part of it, right? So this might not be present in civil services syllabus, but it is actually, right? Similarly, this topic continents and ocean. So this is the only difference. In geomorphology, nothing, there is no difference. Both syllabus of both of them is same is the case with remote sensing, right? In structural geology also, most of the syllabus is same, but in IFS syllabus, these two topics are mentioned additionally, right? One is superposed deformation and another one is introduction to petrofabric, right? So we have not seen question on petrofabric in civil services, but we have seen questions on petrofabric in Indian forest services, right? This is because this topic is explicitly mentioned in Indian forest services, right? But they have indirectly asked this topic also in paper 2 in metamorphic in civil services, right? So that is the thing. So I'll share this PDF with you on the portal. So you go through it and you try to memorize the syllabus. You maybe take a printout of it and you can go through it multiple times, right? That is the thing. Plus, whenever we will start any unit, we will discuss this in detail at the very starting, right? So this is it. So now we will start with the first unit, right? All right. So like today we won't take a very long like it will be a relatively shorter class itself, right? So like I mentioned, let's go through the syllabus again, syllabus of general geology. So these are the bullet point, right? So we can count, there are just 10 topics or maybe some subtopics mentioned in this syllabus of ours, right? So the very first topic mentioned in the syllabus of general geology is what? I hope this is visible, is the solar system and meteorites, right? So we'll do this today and we'll do meteorites and this topic tomorrow, right? So like just I want to tell you, like there were some messages they want us, they were asking that, sir, will you be telling us what is important in a particular unit, right? So this we'll do, right? So we can analyze previous question. What we can say is that from this topic, solar system, UPSC is not asking much, right? So it does mean solar system means it is about origin of solar system and some other features of solar system which UPSC is not asking. But this topic, meteorites, it is very, very important, and this is all asked almost every year. This is asked almost every year in CSE as well as IFS, right? And even at times they will ask you about meteorites in paper 1, general geology, or they can ask about meteorites in paper 2, geochemistry, right? So like let's see the syllabus of geochemistry. Right. So see here also again this topic of meteorites is mentioned here. So that is why this topic is very, very important, and they are asking about meteorites each and almost every year. Right. So we'll do it in good detail. Right. So now today, just to start off, we will start with solar system. Right. Even before starting that, I want you to go through some of the questions, right? We'll do a very detailed previous year question analysis at the end of the chapter, but just to start off, I will show you some of the questions, right? This is our compilation of previous year questions for civil services as well as forest services, right? And we will share this to you on the portal, and we'll go through all this at the end of the at the end of the chapter, right? So this is previous year question topic wise compilation of civil services, and this is of forest services, right? This is topic wise compilation. So like this is the topic, solar system and meteorite. Like they have asked on solar system last time in 2007, and they asked just write a short note on solar system, right? And in meteorite they ask again and again. That is why I have not used it here. Right? Even in 2017 they asked a question, and it was indirectly on nebular hypothesis. Right, in IFS. So there was a question in 2017 on nebular hypothesis, right? So similarly, we will go through all these, but before that, we'll just go through last 4 years of paper, right? And we'll see what kinds of questions are asked, right? So this is civil services paper 2021, right? Which happened on 16th of January. Right. So in this question, see you can also see using this, you can also see how UPSC asks questions, right? So UPSC asks, this is paper 1, and paper 1 they will ask 2 questions, right? This is section A. In section A they will give you 4 questions, question 1, 2, 3 and 4, right? Question number 1, as you must be knowing, is compulsory. In section B, again there are 4 questions, 5, 6, 7 and 8, right? And in this, question number 5 is compulsory, right? And in total you have to attempt 5 questions, right? In total you have to attempt 5 questions. 1 and 5 is compulsory, and you have to attempt 3 more questions. So you can attempt 3 more, and you have to choose 1 question from each section, at least 1 question from each section, right? So maybe you can choose question number 1 you have to write, you can choose question number 2, and then maybe you can choose question number 6 and 7, something like that, right? You can do it. So this is how. So you will see how UPSC frame its question. The question number 1A, this is, I hope it is visible in your screen. Is it visible?
Yes,
Anybody?
sir. Yes, sir.
Okay. So the first question is, explain the ring of fire, right? So I think this question comes from which part of our syllabus? This comes from we have earthquake as well as volcano topic in our general geology syllabus, right? So like I again want you to go through the syllabus. The first topic is solar system, meteorites. Second is about origin as well as interior of earth, right? And age of earth. The third is about volcanoes. Then they want us to know about earthquakes, and then they want to know us about plate tectonics. So all these island arc, trenches, mid-oceanic ridges, continental drift, seafloor spreading, these are in a way all part of plate tectonics, right? And there is also topic known as isostasy, which is also in a broader theme of plate tectonics itself, although, right? So these are the topics which UPSC want to us to know, like solar system, interior of earth, volcano, earthquake, right? Plate tectonics, and then there are 3 specific. This is also orogeny. Pyrogeny is nothing but part of plate tectonics itself, and same also, right? And then about radioactivity and age of earth, right? I hope you can remember this much, right? Volcano, earthquake, plate tectonics, radioactivity, and interior of earth, right? So now let's see the questions. So we were doing 2021 IS paper, right? So they are asking about ring of fire. So it is basically plate tectonics only, right? We study this in earthquake as well as in volcano, and this you even answer using your general studies knowledge, right? It is very easy, and this is a 10 marker questions, right? So this is general geology. The second question in compulsory they will give from remote sensing, that is unit 2, remote sensing or geomorphology, right? And the third question they will give from structural geology, right? And then again this is also from structural geology, and right, and this one is also from structural geology. So basically they have given sorry, this is stereoscopy, this is from remote sensing, right? So what they have done, they have given 1 question from general geology, 1 question from geomorphology, 1 question from remote sensing, and then 2 questions from structural geology. So these are the units of paper 1, right? First is general geology, second one is geomorphology and remote sensing, they are given together, then third is structural geology, right? Now, and in section we have paleontology, Indian stratigraphy, and hydrogeology as well as engineering geology. These are given in single unit, right? So this is how UPSC mix up. Similarly, see, so they have asked only one question in question number one. That is pretty simple, right? Ring of fire. What else question they have asked from general geology? This is 2A. That is what are lithospheric spheric plates. Again, they are asking this from plate tectonics and discuss the theory of plate tectonics, right? All these things. What are the plates which were involved in earthquakes during 2002 tsunami, right? So very easy. You are aware with your geography knowledge also and general studies knowledge also. Then 2B they are asking from geomorphology and 2C from structural geology, right? One question from each unit. So one point you can take away is like you cannot leave any unit. Right, like there are some examination, some maybe in state PCS they do like that. They will give question number 2 entirely on general geology, like 2A, 2B, 2C, all general geology. Then 3A, 3B, 3C they will give on geomorphology, and then 4A, 4B, 4C they will give on structural geology. So in that case you have option and you can skip maybe structural geology or geomorphology, right? And you can do something like that. But that is not possible in civil services or in forest services, because UPSC will make you write each and every unit, right? So you cannot leave any unit. You have to cover 100% syllabus. That is the first takeaway, right? Then what other question they have asked from general geology is this one. Like 3A is again they have asked from geomorphology, and this is from general geology. That is what is isostasy and what are the different theories regarding isostasy. So I think you remember isostasy was directly in syllabus, right? And they are just asking what is isostasy. So there is not much, difficulty in how they frame the question. And this is structural geology. Then again, another question on general geology is where they have not asked. So they have asked only 2 questions on general geology, right? 3 questions on general geology in 2011. So they are pretty straightforward, right? So let's see other. This is civil services 2019, right? So I hope it is visible. I'll zoom in for you. So here they are asking about dating methods, right? Age of Earth is, so they are asking from age of Earth. So one of the way of determining the age of Earth is dating. So they are just asking about direct and indirect methods of knowing the age of Earth basically, right? So very simple. What other question they are asking? Again, they are, now this question is from geomorphology. This is from remote sensing. This is from again geomorphology, and this is from structural geology, right? Now again they are asking is this question from general geology. So what are the evidences supporting continental drift theory, right? So they're directly asking about continental drift. It is also part of our syllabus. Very easy. Then here they are asking about what is volcano, right? Very simple. What is volcano? And this would be of 5 marks. And similarly, they will ask you what is earthquake, something like that, right? So see, even a, I think 8th class student can answer this question. And then they are asking, tell us 4 landforms, right, associated with positive reliefs and negative reliefs related to volcanoes. Very simple, right? So what I mean to say is that in this unit or even in entire geology, there is no chal kapat, right? You understand chal kapat, right? There is no no manipulation or like that. UPSC simply stick to syllabus and they frame very simple questions for you, right? So that is one takeaway. Another question from general geology is what are island arc, right? They are also given directly in our syllabus, right? They tell us some characteristics of island arc and all these things and draw a diagram, all these things. Very easy. So nothing difficult in it. So these were the question asked in 2019, right? Then again, this is civil services 2020, last year's paper 1. Now see what are the questions they are asking here. Sorry. Right. So again, the favorite question of UPSC is here. What is discuss different types of meteorites? Right. We discussed 2021 and 2019. So in that year, they didn't ask meteorites in paper 1, but they asked meteorites in paper 2. Right. So you will get this topic somewhere. If not in paper 1, you will get it in paper 2. So this is your superstar topic, you should like mug it up like anything, right? So they will ask this the very simple question, different types of meteorite. This is from general geology, right? What else from general geology? Simple. Explain internal structure. Internal structure, interior of Earth is directly in syllabus, and they are just asking to explain that. Just a topic, and also tell us something about discontinuities, right? You must have even in GS, you must have heard about there is Moho discontinuity, right? There is Gutenberg, Lehman, all these, right? So we'll cover them quite easy. Then what else? Uh, Simple. They're asking about earthquake. So they're telling just tell us about what is the magnitude of earthquake, what do you mean by intensity of an earthquake, right? And not on damage caused by earthquake. So these are all. This is definitely a GS kind of an answer, right? So we'll do it pretty well, right? What else? They are asking again plate tectonics. They are asking about tell us something about seafloor spreading. Nothing, and give us 4 evidence. So they are essentially asking just seafloor spreading, right? Plate tectonics say. So this is very easy. We'll see couple of more question paper and then we'll move on to the topic. This is, I think this is 2021 IFS paper. Like this just happened on maybe just 20 days ago. I think this was on 3rd of March. Right, 3rd of March 2022. Like what they asked in this paper from general geology, they are asking just the evidence in favor of plate tectonics theory. So see, they are just sticking to the syllabus and they are just asking evidence. So there is not much chal kapat or very difficulty, very simple questions they are asking. Here they are asking, I think, 2 questions from general geology in compulsory, right? So the one question they are asking is just evidence of plate tectonics, and they ask about how do we come to know that the core of Earth is chiefly made up of iron, right? So basically, this is a question on interior of Earth. Right, Earth's interior. How do we so an age of Earth, right? Very simple question. So this we can do it. So just we have to write the content of this topic, and you will get full marks on it, right? What else did they ask? Again, the favorite topic of UPSC is meteorites, right? So they asked meteorites. They didn't ask meteorite in Civil Services 21, but they asked meteorite in IFS 21. Right, so you will write meteorite and nothing different, just different types of meteorites are based on composition, mineralogy, texture, all these things, right? And how do they help in the study? I think this is not much visible, but this is a question, right? Then again, how do earthquake cause damage, right? And how we can reduce the risk of earthquake. So there is a topic, earthquake resistant structures, right? And some other. So that is what they are asking. Then similarly, example, principle of determination of absolute age of rocks. So by age of Earth, age of rocks, radioactive dating, they are trying to ask you, right? And the last question is they didn't ask any question and 4th part from general geology, right? This is what is weathering, but this is more part of geomorphology and different process of weathering. Very simple, right? So this is such kinds of questions they are asking, and this last question we'll last paper we'll see, and then we will move on, right? So here again, this is 2020 Indian Forest Services geology paper. So here they are asking simply write a short note on island arc and volcanic arc, right? Then what again they are asking? They are asking about discontinuities, right? Seismic or compositional layers, basically interior of Earth. Again, they are asking on earthquake, seismic waves, right? Very simple. Again, see, we saw this question where? We saw this question in 2017, I think, or where? What is volcano? Discuss elevated and depressed landforms. वहाँ पे उनकी भाषा थी discuss positive and negative landforms, right? What is volcano? Here they are asking what is volcano. So see, the question is getting repeated within a matter of 3 or 4 years itself, right? So this is just an example of how the questions are very much repeated, right? Similarly, they will ask what is earthquake and something like that. So see, this is again a repetition in its own. So like what my purpose was of doing this was to let you know that you don't have to complicate things. Just stick to these golden words, written in by given by UPSC, make very good quality notes on them, right? Make diagrams and ratify them, right? You will get very good score in this general geology. And another thing is like that, since this is a very simple, relatively very simple syllabus of this unit, so almost almost everyone, even people from general studies background, they will be able to attempt question on this. So for you, it is important that you make your answers rich in diagrams and in keywords. Now you should use technical keywords, right? And you should try to incorporate a lot of diagrams in your answer, small diagram. If you are able to do these two things, you will score pretty good marks in general geology, right? So, all right, now we will start with the first topic of general our syllabus, that is solar system, right? So, okay, so I hope the screen is visible. The first we'll start with origin of the origin of the universe. So, like strictly speaking, this topic is not in our syllabus, right? UPSC has not given origin of universe in our syllabus. It is origin of solar system. But ultimately, we have to come to solar system. So it is just a background story. So, right, we'll just we'll just go through an overview of this topic, and then we'll move on to solar system, right? So don't have to go in much detail. And we all know that the origin of universe is explained by Big Bang theory, right? It is a very commonsensical thing. So what is Big Bang theory? What is Big Bang theory? Big Bang theory is about how universe basically expanded, right? From an initial stage of very high density, very high temperature, and like very small volume, right? So this is an initial stage. And what do we call this initial stage as? Anyone? Right, singularity, right? So this Big Bang theory explains how universe expanded from its initial stage of very high temperature. That is, theoretically, or they say that it is like infinite temperature, infinite pressure, density, infinite pressure, and very little volume. So it is just like a point or a very small tiny ball, right? This was all universe. All the matter, all the energy of universe was confined to a single point, which is known as singularity, right? So this story starts around 13.8 billion years ago, right? So what happened around 13.8 billion year ago is there was there was an explosion, right? There was an expansion from this single point, right? And right. So like that is the thing, and from there the whole universe expanded, and it is what we have. It is there, right? So firstly, why this Big Bang theory is accepted? Because this Big Bang theory, uh, it comprehensively explain a lot of observations which we have observed in the modern times, right? From our various modern equipments like telescope and a lot of our exploratory vehicles, we get to know few observations like most of the universe is abundant in light elements, right? So most of the universe is made up of hydrogen as well as helium. There are obviously other elements also, but the bulk of the universe is composed of light elements. So this theory explains this. Also, there is an abundance of cosmic microwave radiation, right? So basically, in even in all the galaxies, in almost all part of the universe, we will find these microwaves, right? So there is a background microwave radiation. So this also explained that in a way or the other, right? And there's also it also explains a lot of large scale structures, right? Large scale structures means galaxies, right? The fact that all the galaxies are galaxies are moving away from each other, like they are expanding, and also they are accelerating, right? So this is a common knowledge even from your general studies, that the universe is expanding, and universe is expanding at a faster rate, right? Like the the velocity is also increasing, yeah, it is all accelerating. So all these things are explained by this Big Bang theory, right? So there is Big Bang theory is also compatible with Hubble's law, right? This is Hubble-Lemaitre law, but you can also call it Hubble's law, right? And which is, what is Hubble's law? It says that farther away the galaxies are from the Earth, faster they are moving away, right? So suppose this is Earth, and there is some galaxy here, some galaxy here, some galaxy right here. So the farther the galaxy, they are moving even at a faster rate, right? There is V1, there is V2, there is V3. So V1 is greater than V2, which is greater than V3. That is, there are some other factors also, mass and the size and all these things. But in a very generic and a layman language, this is the law, which is saying. So we don't have to go in detail. This is not part of our syllabus, but just to start off, right? And like all these observations, which this Hubble law, they can be seen in this. You must be aware about Hubble telescope. So all these things are pretty much visible from these. Like if you see this Hubble ultra deep field images, you will be able to see the images of actual start of the universe, right? So basically right, so like in the modern time, we are able to see in the past. So right, so like why is it so? Why we are like today we are able to see live what happened in the past using all these images? It is because light takes some time to travel, right? Suppose this is Earth and there is some galaxy, or there is some point in the space which is 10 billion light years away from Earth, right? So something happened at this point which is 10 billion light years away, right? So light will take 10 billion years to come to the Earth, right, after this event has happened. So that is why, right? So it takes 10. So today whatever we are seeing, it is what happened in the past. So all these images are recreation of the events in the universe which happened in the distant past, right? So basically this is all. This is just the summary of what happened in the Big Bang, right? So what happened, in your notes you can just make a simple flow chart, like what happened in the initial stage. All the matter of the universe was confined to a single point, which is known as singularity, right? And then around 13.8 billion year ago, what happened? There was explosion, there was expansion, right? The event which is known as Big Bang, right? And what happened after that? After initial expansion, the universe cooled sufficiently, right? So there was cooling, there was a lot of thing happening, right? Creation of matter, creation of subatomic particles, right? And then subsequently creation of atoms, and from the atoms the matter evolved, and we got stars, and then subsequently planets and satellites and all these things, right? So this is it. So this is singularity. After initial expansion, there was cooling. In this cooling, a lot of subatomic particles were formed. So like what are subatomic particles? What are subatomic particles? Anyone? These are proton, electron, neutron, right? So yes, right, Kaushal is saying proton. So proton, electron, neutron, these are subatomic particles. And then atom form. So this is what which was happening, right? Then what happened was, in the primordial or the earliest giant clouds which was formed after Big Bang explosion, right, the most abundant element was hydrogen, right? It is the most abundant, hydrogen, along with helium also, and some lithium, right? So these are very light elements, right? These are very light. These are the lightest element in periodic table. So this hydrogen and helium, they were there. So we have a lot of hydrogen and helium. Then what happened was all this hydrogen and helium, they coalesced. What is collision? That is, they came together, right? They came together and form a lot of chunks, right? Form chunks, right? I hope you are also making notes. So see, what we'll do is like you make your notes, at least make these flow charts, and we have also prepared handwritten notes for you, right? I'll show you the handwritten notes. We'll share these also. So these are handwritten notes, right? So whatever we'll do in this today, everything is there in the handwritten notes. So your note should be something like that, like this, right? Just in bullet points, in short bullet points, just right. And even I think these are also very detailed notes, right? So like in the morning in our private Telegram group, I shared a link regarding how to make notes, right? So after the class, I would like every one of you to go through that video, right? That is also available on the YouTube, with this name, right? This name of note making strategy in geology optional, right? So for optional, it is very very important that we make notes, because like if this was a, if this was gate or jam or any objective examination, MCQ based examination, even then even if you don't have handwritten notes, maybe you can score better, because you just have to ultimately recall there, right? But in exams like IAS, IFS, right, even in GSI, geoscientist mains examination, these are all subjective exams. In subjective exam, you have to generate your own content, right? And you have to write it in 3 hours time. So it is very important that you have your own handwritten notes, and which you can revise multiple times. You can mug it up, you can draw diagrams, and you can innovate, and only then you will be able to score good marks, right? So it is very important to have handwritten notes, self handwritten notes, uh, right? So do it, and if you want some help, you can see that video which is also uploaded on the portal, right? So there I've talked about how you can make notes. You can make notes in 3 layers, right? So you see, and this note which I am showing you, this is basically layer 1 notes. These are very comprehensive, very good notes, right? You should make notes something like that, and when you have revised them a couple of times, then you can make your second and a brief note, right? So that is it. So like, again, coming back where we were. So basically this is it, right? Right. So what happened? This was singularity. Big expansion happened. Then cooling. From cooling, what happened? A lot of subatomic particles, they generated from subatomic particles. They coalesced to form atoms. We got lighter elements, hydrogen, helium, all these things. And with time, these hydrogen, helium, they coalesced and they form heavier elements, right? And then subsequently, with more gravity, they forms stars and galaxies and the planets, and what we have today, right? So this is some very basic of origin of universe, right? Now, like, one thing I want to tell you, that just now I said you, when there was big bang, the earliest universe has hydrogen and helium. Like most of the matter, it was of hydrogen and helium itself, right? So from hydrogen and helium, how other heavier elements were formed, right? So does anybody have any idea how other heavier elements were formed? In the earliest time, there were only hydrogen and helium. Even today, hydrogen and helium are the most abundant elements, right? This we will study in geochemistry. But we also have, what, carbon, oxygen, nitrogen, sulfur, and a lot of other heavier. We have iron, right? Even uranium. So how these heavier elements are formed from the earlier lighter elements? Anybody have any idea? Kaushal is saying Fusion, right? Fusion. Yes, very good. Right. So actually, they were formed through the process of fusion. Right. So fusion is what is fusion? Fusion is a process in which lighter elements combine to form bigger elements. Yes, Surya Prakash is saying due to intense pressure and temperature. Yes, so exactly, we will come to that point. So firstly, fusion. Fusion is a process in which smaller, like two hydrogen nuclei, they can combine to form helium. Right. Similarly, helium and hydrogen, they can combine to form lithium, and similarly some other elements like nitrogen, oxygen, iron. All these can be formed through the process of fusion. Right. There is also another process which is known as fission. In fission, what happens is that a bigger nuclei break up into two smaller nuclei. But in fusion, right? So this was the earliest the process in which heavier elements were formed. Right. So then there is another terminology which you should remember. You should dump in your exam is this term nucleosynthesis. Right. So what is nucleosynthesis? Nucleosynthesis is a process of creating new atomic nuclei from pre-existing protons. So basically this process of creation of elements, we call it nucleosynthesis, right? So basically, just like Kaushal and Surya say that they are formed under through a process known as fusion, right? So like one thing is there for fusion, what is the need, right? Like Surya was saying, it needs intense pressure and temperature, right? So for fusion to take place, actually fusion is about nucleus, right? There is nucleus, and what is the charge on nucleus? Charge on nucleus is positive, right? So we know that when two positive, right, same polarity objects come together, what happens is there is attraction or repulsion.
Repulsion.
Yes, there is repulsion. So, and this is electrostatic force, right? It's electrostatic repulsion. But whenever the temperature is very high, these electrostatic repulsions are overtaken by nuclear forces. Right? So these nuclear forces overtakes this repulsion and they fuse together. Right? They fuse together through the process of fusion, and newer elements are formed. Right? So, but for this to happen, or for this repulsion to go away and nuclear forces to take over, a very high temperature is needed, right? So when we can get very high temperature, right? So one event where very high temperature happened, it was near Big Bang, right? When the Big Bang happened, it was a blast and temperature like was pretty high, right? Another thing is, like, you must have heard about supernova explosion, right? Right. So like supernova is basically a stage in the life of a star, right? So, although our sun, it will not undergo in this supernova explosion, but a lot of stars, they go in this stage of supernova explosion. So what happens is that when the fuel of any stars, it get exhausted, the star started collapsing on itself, right? So when it start collapsing, the temperature increases, and ultimately there is an explosion which we know, which is known as supernova explosion. So during at that time, the temperature rise significantly, right? And that provides condition for fusion to happen. So this we call as explosive nucleosynthesis. The first is we call is Big Bang nucleosynthesis, right? So during even during the time of Big Bang, some heavier elements might have formed, right? Some elements formed during supernova explosion, right? Similarly, there might be something happening inside a star, right? Like in the center of sun, a lot of reactions happen. So sometimes due to that, there might be uh, great increase in the temperature, which might lead to formation of these. And then this is galactic nucleosynthesis. So this is basically cosmic ray spallation, right? So basically cosmic ray are high energy electromagnetic waves, right? So basically this is a fusion process. This is essentially a fusion process. So through this process also, uh, these new elements can be formed, right? So basically we don't have to go in detail of all this. It is just a very good keyword to have with us, and even we can use it in exam. And right, so ultimately we want is to come to the evolution of solar system. So I hope it is understandable. I hope it is not that difficult, right? It is like pretty easy, right? You can use these keywords, and we will also provide you these handwritten notes. So this is all the right. So basically, like I just we are revising. Origin of universe, it is explained by Big Bang theory. Time is 13.8 billion, right? And we follow Big Bang because it explains certain observations to us, which we have observed through modern equipments, right? And after initial Big Bang, what happened? There was cooling down. When there was cooling down, there was development of formation of subatomic particles like proton, neutron, electron, and subsequently atoms, and subsequently various elements like hydrogen and helium, right? Then this hydrogen and helium, when the conditions were ripe, like first was at the time of Big Bang, another was when the stars experienced supernova explosion, right? Or maybe due to cosmic uh, rays bombarding the heavier metals, all these things, there was generation of other elements also, right? Mostly due to process of fusion. So this happened, right? So this is how all of the universe was formed, right? All of the universe was formed. So this is very simple. Now we'll come to the part which is important for an exam, right? Which might be asked in exam. That is origin of solar system, right? So it is in the continuity itself. But firstly, like what I want to tell you is that can anybody tell me when human life evolved? When human life any timing? So like humans come into Earth around 2 million year ago only, right? So like from 2 million is just 20 lakhs, right? 20 lakh year. So basically this solar system, the cosmology, right, astrology, the astronomy, this has been very fascinating to humans right throughout its history, right? So there were a lot of philosophers, and then after 1915 1500 AD, we got a lot of technological development. We developed telescope, right? And like presently we have Hubble telescope, and we also even send a lot of missions to Saturn, Uranus, all these things to study the universe. So we have a lot of data and we have a lot of observations. So there are certain observations which we have, right? So any theory which to be accepted as a origin of solar system, it should have these 4 5 observations. It should satisfy these 4 5 observations, right? The first observation is that all the orbits of a planets are prograde, right? What is prograde? Like in our solar system there is sun, right? There is sun. So if you will see somewhat from the north pole of the sun, you should see that all the planets, they are in the solar system, they are revolving in anti-clockwise direction, right? Maybe this is Mercury, Venus, Earth, Mars, Jupiter, all they should revolve in anti-clockwise direction. So that is the first observation, and this is true for all the planets, right? Like somebody in YouTube, they are asking that like what Mercury and Venus, they have opposite direction. So actually that is wrong. Mercury and Venus, they have anti-clockwise rotation, right? They rotate. Their rotation is different than the other planets, but they revolve. Here I am talking about revolution. So they revolve in this anti-clockwise direction itself, right? So that is not revolution, that is rotation which you are talking about, right? So I hope this is clear. Then all planets except Pluto. Pluto is now not a planet anymore. So all the planets, they also have a orbital plane that are inclined by less than 6 degrees, right? So another observation is another observation is just okay. Just give me a minute. I open to it. Okay, another observation is that all the planets, they are in the same orbital plane, right? They are not inclined. Like suppose this is sun, this is sun in middle. So this is not right. Suppose this is planet 1, this is planet 2. So they are not, inclined. They are more or less on the same plane itself, right? This is Earth, so the plane is same. The inclination of the orbit is not more than 6 degrees, right? So they are all in the same plane itself. This is sun, and this is the path of the various planets, right? So this is another observation. The third observation is that the terrestrial planets are dense, rocky, and they are smaller, while the Jovian planets are large and gaseous, right? So what are terrestrial planets? What are terrestrial planets? They are inner planets, MVEM. And what are Jovian planets? They are Jupiter and onwards. Right? So this Mars, Venus, Earth and Mercury, Venus, Earth and Mars, these are terrestrial planet. So we know that these are all rocky and they are dense. And these Jovian planets are gaseous. They are large and they are gaseous. So our theory should explain this one also. And the final point is that the angular momentum should be conserved, right? By principle of angular momentum should be conserved, right? And if there is a change in angular momentum, the theory should explain that, right? So these are 4 basic observations which we have and which should be satisfied by the theory, right? So basically, like I said that this evolution of solar system has been fascinating, or this has fascinated a lot of philosophers, a lot of physicists, geographers, geologists. So a lot of people have come up with various theories, right? So there are n number of theories, right, put forward various geologist or physicist, right? So then one is tidal theory, another one is this planetesimal hypothesis by Chamberlain, right? Then there is protoplanetary capture theory, and there are many other theories, right? In today's time, all these theories has been discarded, right? All these theories has been discarded, and I don't think you have to go we don't have to go in detail of all these things. Firstly, UPSC is not asking questions on this only, and even if they have asked, they have always stick themselves to, like, they will generally ask us, tell me something about solar origin of solar system. So if they are asking you that, you write the most modern view, which is the most accepted view of solar system, or sometimes they will ask you which we call as nebular hypothesis. Right. So this is the most modern theory of how the solar system was evolved. Right. It is also sometimes known as SNDM. Right. Solar Nebular Disk Model. Right. Or Nebular Hypothesis. Right. In some books they even write it as Protoplanetary Hypothesis. Right. So it is a bit confusing, but we will just remember it as Nebular Hypothesis or SNDM model. Right. Solar Nebular Disk Model. So we'll go in detail. If somebody want to study these also, which are all discarded, I can give you content on them, right? But I think it is not of much use, right? But if you want to have an overview without making any notes, I can show you, right, what these theories suggest, right? So like before this theory, like after Big Bang, there was this theory. Like I also in YouTube, somebody was asking about why sun will not be, will not end up as supernova explosion, right? So can anybody tell me why sun will not end as supernova explosion? Anyone? Kaushal is saying small size, right? Very good. So basically, you have heard about Chandrasekhar. There is, he got Nobel Prize in physics, right? So there is a concept of Chandrasekhar limit. All these things is not part of our syllabus, but just as a curious discussion, I'm telling you. So he got Nobel Prize. So he said that any star which has a size of which has a mass of more than 1.4 times mass of sun, like which has, so it will have different path, different life pathway, and the one which has less than this mass, they will have different, right? So like these are various stages in evolution of a star, right? Firstly we call it a protostar, right? Then it becomes proper star. But if the size of the star is same as that of sun, right, or maybe smaller than 1.44 times the mass of the sun, it follows this path. It earlier, firstly it becomes a red giant star, then it becomes a white dwarf, and it becomes a black dwarf, and it dies, right? If the size is smaller, it is very large, larger than sun, so our sun will follow this pathway, right? It becomes a red supergiant star, then it becomes a supernova, and then after supernova, it will die, and it will either become a neutron star or a black hole, right? So it is not important to you remember all these things, but just as a general awareness, you can remember all these points, right? So stages are protostar, red giant star, then if it is smaller in size, it will become white dwarf. If it is in larger in size, after red giant stage, it will become a supernova, and then ultimately a neutron star or a black hole, right? So this is the thing. So basically, what we were doing is, we were doing was evolution of solar system, right? So there are various theories. The most accepted theory is nebular hypothesis. This is the one which is asked in exam, and this is what we will do. But right before this nebular hypothesis, there were some others, right? There was one by Chamberlain, right? Chamberlain and Moulton. So they were biparental theory. Like they were explaining how the solar system was formed, right? So they say that there were two parents, right? One parent is the sun, which we have today, and sun has some other, there was some other star also, right? So there was some other star, we'll call it star number 2, right? So what happened is that this hypothesis makes a case for biparental origin of the solar system, right? You don't have to write this in exam, right? This won't be asked in exam, but just to have an overview, we are doing it, right? So in this, what happened was planets were formed due to mutual interaction between sun and another star, right? This is sun and we have another star, so there was some interaction between them. What happened was when this another sun, it came close, another star, it came close to the sun, right? There was some distortion in the sun due to gravitational pull. Gravitational pull of another star. So what happened was the sun was distorted. Basically, there was cigar like shape was formed, right? So the sun was distorted, and what happened was, as the larger star came near to the sun, tidal distortion. In geology, or in this subject, tidal means gravity, right? Tidal hypothesis means gravitational pull of another star. So this tidal distortion were raised on the surface of the sun, right? The sun got distorted, and then with time what happened was this material got away from sun, right? This became the sun, and all this material, it started revolving around the sun, right? And ultimately these material, they coalesce, they came together, and they form various planets, right? So basically they are saying there were two parents. One was sun, one was another star. Sun is the mother of solar system, right? So all the planets which are there, they are nothing but they are primordial part of sun itself, right? And the father was some another star, right, which now got away from our solar system. But there was a time when it came close to the solar system, or it came close to the sun, and it led to this distortion, which leads to creation of various planets in the solar system, right? So this was the basic theory. Like as this particle revolved around the sun, their orbit intersected and they coalesced, they collided, and ultimately they formed planet. This is the simple theory, right? So you can just write this. Then there was some another theory which is known as gaseous tidal hypothesis. Tidal means gravity, right? So this is by J.J. Jeans and Herald Jeffrey. So we call it the tidal hypothesis or gaseous. So it is also biparental in origin, and it is pretty much same like the planetesimal hypothesis by Chamberlain and Moulton, right? So I'll come back to the main slide, and there. So what you can do is like if you are ever asked about this genesis of solar system, what you can do is you can just mention their names, right? So there were a lot of theories, and most of them are discarded, right? So like theories of this tidal theory of J.J. Jeans and Herald Jeffrey, or by Chamberlain and Moulton, they are what? They are theories based on biparental origin. So this is a keyword, right? It should be in a notes. That is biparental origin. So iska basic, what are the basic concept of this? Is there was a ancient sun, and there was another star. When this star approaches the sun, it led to distortion due to gravity pull. It leads to distortion on the surface of Earth, and sun. Something like this, there was distortion on both the sides of the sun, and ultimately these parted away from sun, and they started revolving around sun, and ultimately these particles itself coalesced and formed various planets. This was a very simplistic theory, but this theory has a lot of lot of shortcomings, and they are discarded today. Similarly, there is capture theory and some other theories, right? So you don't have to go in detail. If you have notes, you can just write this much: biparental origin, and this is what something which happened, right? So this was these theories. Now most modern theory is known as the nebular hypothesis, right? This nebular hypothesis also fits in well in the paradigm of Big Bang, right? Big Bang hypothesis or Big Bang theory, right? So we'll cover this, and then we'll end the class today, right? So what is nebulae? Anyone? You must have heard about solar nebulae or nebulae a lot of time. So can you tell what is nebulae? Anyone? Gas clouds, right? Kaushal is saying nebula is a gas clouds, right? Anything else? Hot gas cloud. Shridhar is saying hot gas cloud, right? So yes, basically they are essentially gas clouds, right? Somebody also saying in the YouTube that it is basically these are the birthplace of stars, right? Yes, nebula is a birthplace of stars, but basically nebula, these are regions, or these are the regions in the space which have higher than average concentration of gas, dust, and plasma, right? Suppose this is universe, like I'm wrong, we cannot put a boundary to the universe. So suppose this is a whole universe, so you will find some amount of this gas, dust, and plasma everywhere, right? But then there are certain regions where there this concentration of this gas, dust, and plasma is much more than the background level, right? So we call this as a nebula, right? This as a nebula. So these are basically regions in the universe where higher than average concentration of gas, dust, and plasma, right? Gas and dust, these are found, right? So this is the thing. Now this nebular hypothesis theory, it suggests, or nebular hypothesis, it suggests that how the solar system was generated, right? It says that after this Big Bang, there was, this solar nebula present in the universe, right? Now there is the presence of the solar nebula, right? It is granted. So this solar nebula initially is in equilibrium, right? This is initially in equilibrium. Like, please focus. This is important, right? So this is initially in equilibrium, but right, it is in equilibrium because suppose this is roughly a nebula, right? This is in equilibrium. There are gas particles, there are dust particles. They are moving in this direction, maybe this direction, random directions, right? Random direction. So basically, the gravity is diffused, right? Now, what happened? There might be some disequilibrium. There might be some disequilibrium, or you can say some disturbance in this cloud of gas, right, or cloud of dust. So what happened was, whenever there might be some disturbance due to passing of some galaxy, right, or this pressure wave created by some galaxy or something. So there is some disturbance, right? When some disturbance happened, this packet of gas, this nebula, start to collapse itself, right? So what happened is that, suppose this is the nebula. So whenever there is some disturbances, the center of gravity, right, there is some center of gravity. Like even in this nebula, even when it was in equilibrium, it must have some center of gravity, right? So like whenever there is some disturbance, all these cloud of gas start collapsing itself, right, towards this pull of gravity, towards center of gravity, right? So they start collapsing. So when they start collapsing, what happens is couple of things happened, right? Whenever they start collapsing, couple of things happened. What happens is, firstly, you tell me, suppose this is center of gravity, and suppose there is an object, there is a dust particle here, right? So as height, or as the distance from the center increases, right, distance from center increases, what happens to potential energy? Anyone? Potential energy increases, right? Potential energy is higher as the distance from the center increases. Now when all this is collapsing, what will happen to potential energy? Whether it will increase or it will decrease? Anyone? Yes, Kaushal is saying the potential energy will decrease, right, whenever the nebula is collapsing, right? So basically, when the potential energy is decreasing, so what is happening to the potential energy? The energy is getting converted to heat, right? This energy is getting converted to heat, and in this heat, what happened? Fusion will start, right? This heat will be sufficient enough to start the process of fusion, right? And when fusion start, what will happen? All these hydrogen nuclei, they will start fusing hydrogen and helium, they will start fusing, and newer elements will start forming, right? So this is the one thing which is happening. What is the second thing which is happening is, it also start rotating, right? It start rotating. And the third thing which is happening is that conservation of angular momentum causes the remaining cloud to flatten out, right, as a disk, right? So firstly, this diagram, this is a 3D image, right? This is 3D. The solar nebulae is present everywhere in the space, right, in the three-dimensional space, right? So what happens is that, like suppose a object is rotating, right? Even if you are rotating, and you must have seen in your 9th and 10th standard a experiment that if you are rotating and you have your arms broadened, right, they are outside. If you take your arms closer to your body, what will happen to your rotating speed? Your rotating speed will increase, right? Your rotating speed will increase. So that is a very basic experiment, right? So whenever this all these clouds is coming towards the center, the rotation speed of this solar nebulae also increases, right? And whenever this speed increases, but there is also differential in the speed, right? Differential in the speed. If speed is this rotation speed of any point on this earth, right? Suppose this is earth, or on this circle, it is highest in equator, right? Because at the equator the diameter is maximum, right? So it has to cover the maximum distance in the same time. At the pole, the velocity, the rotation velocity is minimum, right? So because of this, there is basically flattening out. Even you will see earth, because of this rotation itself, the diameter of the earth near equator is higher than at the pole, right? If you will see the radius of the earth at the equator, right? R at equator and R at pole, you know that R at equator is more than R at pole, right? So this is the same flattening, right? So here, because of this phenomena, what happens is that this nebula, it flattens out, it flattens as a disk, right? It flattens as a disk. So like suppose this is sun, and all this nebula, all this material, this is not sun, this is the center of nebula, and all this material, it will become in disk shape, with time, in the same plane, right? So if you'll see this diagram, so this is the center of nebula, right? And all these dark colored things, we don't have to go in detail of these things, but all these objects, they will, with time, they will coalesce, they will combine, and these will form planets. So this is nothing but this is the solar nebula. In the center of it, what is happening is fusion is happening, right? This is sun, where temperature is the highest, and around the sun, all these dark objects, they will coalesce and they form planets, right? So there are various steps how this happened, right? So now just as a summary, till now what we have discussed is this only. And right, so now just revision. This is, you can in your answer, you can just draw this diagram, this with whatever we are discussing, right? So what happened? There is solar nebula, there is nebula, right? You all know what is nebula. It is a region in the space where there is higher concentration of the gas, dust, and plasma than the normal, right? And there is some disturbances. What happened? There is some disturbances. So this nebula was initially at equilibrium. With time, there was some disturbances, right? And when there was disturbances, this nebula start collapsing on itself under the force of focused gravity, right? This is what is happening. Then what happened? That potential energy is decreasing. That energy is getting converted into heat, and the fusion is starting at the center, right? Also, it start rotating, right? And due to this higher centrifugal force at the equator, or at the center, it starts flattening. The solar nebula start flattening as a disk, right? This is which is happening, right? Now what happens is that around all those particles around this center of the nebula, they start coalescing, right? So basically, just I forgot a keyword, that is this flattening. So this flattening disk, this has a very technical term which is known as PPD. This flattening disk of solar nebula, this flattened solar nebula, it is known as protoplanetary disk, right? This is known as protoplanetary disk. So how does this protoplanetary disk look like? This is the center, and then there are some material which has which is flattened out here, right? Everywhere they are there, right? So these material which are here, these are known as protoplanets. And isko we call it protoplanetary disk. This whole thing, right, is known as protoplanetary disk. These are all protoplanets, right? Now what happens is that what is happening here, how these planets are forming, is this the process, right? So I'll come back to this. So how planets are formed? Planets are formed through a process which is known as accretion, right? So like accretion. So what happens is that there is this dust, right? Dust particle, gas particle around the center of the nebulae, and they start coalescing, they start colliding, and they will form they will form. We call them as planetesimal, right? So like I'll just again make a this diagram which will explain about the formations of planet. So in exam, this will be asked and you just draw this diagram, right? This diagram is also there on the handwritten notes, but first we will draw it here, and then we will, I'll also share the handwritten notes. So what happens? This around the solar nebulae, we have dust. So what is the size of dust? Size of dust is around, it is in some millimeter to maybe some centimeter, right? And these dust particle, how did they combine? They combine by collision process, which is we call it as collision, right? And collision is just a by chance process, right? So they are combining, so they are getting bigger. This dust particle keeps on getting bigger by coalescing themselves, right? When they become big enough, in some million year, they become what we call them as planetesimal. The technical term is planetesimal. It is like planet-like, right? So these planetesimal have a diameter of over 10 kilometers, right? 10-20 kilometers diameter, right? Then these planetesimal themselves, they start colliding themselves, and we call them as as accretion, right? So this process of collision and accretion, they become even bigger, and when they become in the scale of 100 to 1000 kilometer in diameter, we call them as protoplanets. What is the diameter of Earth? What is the diameter of the Earth? Anyone? Anyone? Yes, 6371. No. Diameter of Earth is not 10 kilometers. Kaushal, right? Diameter of Earth. You search over it, right? We'll study that in interior of Earth also, right? So this is protoplanet. Then this protoplanet, through various process of, again, these planetesimal accrete, we call it accretion, or there was also bombardment, right? This bombardment, they become planets, right? So this you should know. This is how planets are formed, right? So you don't have to, in your notes you will have notes something like this only, right? So what happens is this. Initially there was some disturbance. Due to disturbance, the solar nebulae collapse, right, on itself, right, and it leads to formation of protostar at the center, right, and uske along mein what happens is that there is a formation of disk, and through the process of this accretion, bombardment, planets are formed, right? So this is the diagram. This is nebula. I hope you are able to see this one. This is nebula. This is how you can show as collapsing nebula, right? And then we have protostar at the center, and this whole, we call it protoplanetary disk, PPD, right? So we have protostar, and we have around this protostar we have what we call it planetesimal, whose diameter is around 10 kilometers, right? Then when these planetesimal, they again accrete, right, through the process of accretion and collision, right, they become protoplanets. Protoplanets have diameter in the range of 100 to 1000 kilometers, right? And then again, these protoplanets, they have one special thing is that they are big enough, they are big enough to attract other objects in the extraterrestrial environment, right? So they are so big that they have huge gravity and they will pull other objects and they will keep growing, right? So like presently we have this picture, we have sun there and we have 8 planets, right? We have Mercury, Venus, Earth, Mars, Jupiter, right? Saturn, Uranus, Neptune, all these things. And we have Pluto, and we also have some other asteroid belt. Then we have some other things. So these are all part of that nebula itself, right? We have Kuiper belt post Neptune. So all these things. So this is the present picture of solar system. So this is how our solar system is formed, right? So in exam you can just write. You can what you need to do is that you just need to give reference that solar system. There was a lot of physicists and the geologists like J.J. Jeans, Harold Jeffrey, right? There was Chamberlain. So they all gave theories, and their theories was mostly based on biparental. Biparental. There were two parents, origin of solar system, but these are all discarded. The modern theory talks about nebular hypothesis, right? This is the most accepted theory of the modern time, and the nebular hypothesis says that earlier there was a nebulae, right? It was in equilibrium. When there was some disturbances, right, it start collapsing on itself, right? When it start collapsing, what happens is that potential energy gets converted into heat energy, and at the center of this nebulae there is formation of protostar where fusion happens, and it has its own energy around it. When it is rotating, there was formation of protoplanetary disk, right? From 3D to it become kind of 2D, right? And then with gradual collision, planetesimals were formed, and with time these planetesimal accrete themselves, and through bombardment they form protoplanets, and they evolved in the modern solar system, right? So this just this diagram and few words, you can score full marks on this question, right? So this is all about origin of solar system, right? So what else we'll see in the slide. So again, this is whatever I was talking in that flow chart, all that is written in theory, right? So what is it is saying that planets begin as a dust grain around the orbit of the central protostar, right? So something like that, through direct contact or through self-organization, these grains they start gaining in the diameters, right? Then these clumps in turn collided to form larger bodies, which is known as technically as planetesimal, who has diameter of around 10 kilometers, right? These gradually increased in size through further collisions, right? And also through attraction of gravity, right? And then they become protoplanet when their diameter is around 100 to 1000, right? So this is the one thing how solar system is formed, right? But the last aspect which we need to reason is about these terrestrial planets and Jovian planets, right? So I want to tell you one thing here. So I hope any doubt here, I will explain some other features also, and then we can take up few doubts, right? So all right. So now I hope you will be able to draw that diagram, that flow chart. Now, one thing I want to tell you is that I also said that initially that all these theories should explain why terrestrial planets are smaller in size. Small in size, and they have higher density. Right? And why these Jovian planets, right, which are beyond Mercury, they are less dense, right? and they are like huge in size, right? So see, this is also here itself, right? So this is what this is saying, right? What this is saying, that the inner solar system, that is the region of solar system inside 4 AU, right? 4 AU matlab 4 astronomical unit. Can anybody tell me what is 1 AU? How much is 1 astronomical unit? This is sun, this is earth. So do you know what is astronomical unit? 1 astronomical unit? Anyone?
Sir, time taken by a light to reach from sun to earth.
Yes, actually it is distance, it is not time, right? So that is also a linked subject, but you are right in a way that it is actually the distance between, like Sridhar is saying, it is the distance between sun and the earth, right? So the distance between sun and the earth is 1 AU, right? So the distance of 4 AU, right? This is sun and up to 4 astronomical unit, right? This zone here, in this zone we have Mars. So in this area till 4th astronomical unit, we have Mercury, Venus, Earth and Mars, right? So this area near Sun up to 4 astronomical unit is actually too warm. It is too warm for any volatile molecules like water or methane to condensate, right? So in this area, up to 4 astronomical unit, you won't have all these things, right? Plus, so the planetesimal that form there could only be formed from those compounds which have higher melting points, right? Higher melting points किस metals का होगा? Metals like iron, nickel, aluminium and rock silicates, right? So that is why these planets are rocky in character, right? So like what, again I'll explain it here. So this is sun, and all those area near sun, it is very high in temperature, right? So area up to 4 astronomical unit, it is very high in temperature. So in this place you won't have much lighter elements, right? Like I said to you that the most abundant element in the universe is what? Hydrogen and helium. These are the most abundant element. But you'll see Earth, even atmosphere of Earth, it don't have much hydrogen and helium. Even you'll go to the rocky part of Earth, that is the crust, mantle and core, you won't have much hydrogen and helium, right? So like in geochemistry, we will study that in the crust of Earth, the most abundant element is silicon and oxygen, right? Oxygen is the most abundant, then there is silicon, right? Then there is aluminum, there is iron, right? In the core, what is the most abundant element? Iron. What else? Nickel. Even in mantle, you have mostly silicates, right? So in Earth we don't have much. Same is the case with Mercury, Venus and Mars. So what happens is that due to too much temperature in this area, these lighter elements are not present, right? The only element which can condensate here from solar nebulae was those which have high melting point, right? Such as iron, right? Silicon, aluminum, right? Nickel. And this is exactly what is the composition of Earth, right? So this is a scene. So this is what it is saying. It is saying that the inner solar system, that is the region up to 4 astronomical unit, it is too warm for light elements as well as volatiles to exist, right? So what happens? These planetesimals or these regions have only those compounds, sorry, which have high melting points, right? So which includes iron, nickel, aluminum and rock silicates, right? So like most of the rocks are in the earth, they are formed of silicates, right? Rocks could be also carbonate, they could also be phosphate, they could be halides, right? But most 90% of the rocks, they are of silicates on earth. So that is why this is formed. So that is why these planets which are within 4 astronomical units, they have, they are high density, they are rocky bodies. And all those which are beyond these 4 astronomical units, which we also call as frost line, they are rich in, or they are mostly gaseous, right? They are rich in, or they are composed of helium, hydrogen, and some other lighter elements, right? That is the thing. So this is what these are density. And why they are small? They are small because, like I said, that nebula is mostly 98% of nebula is hydrogen and helium, right? So basically these heavier elements, these silicates, iron, nickel, they comprise of only 0.7% of the total nebulae, right? There is not much of these elements, so that is why they are smaller in size, right? Jupiter is huge in size, Uranus, Saturn, these are all very big in size because they are composed of this 98% of the nebulae, right? Which is hydrogen, helium, other gases, and dust particles. So that is why they are bigger, right? So these compounds are quite rare in the universe, comprising of only 0.6% of the mass of nebula. So these terrestrial planet could not grow very large because the compositional matter is not there, right? So that is the reason. Now similarly, these giant planets means Jovian planets. Jupiter, Saturn, Uranus, and Neptune, they are formed further out beyond the frost line, right? So they are formed beyond for astronomical unit, right? So technically we call it frost line. So you should keep this keyword in your notes. It will give you at least half an additional mark, right? So it is a point between somewhere between Mars and Jupiter where material is cool enough for volatile ice compound to remain solid, right? So this, okay. So these ices that form Jovian planets, they were more abundant than the metal and the silicates, right? And allowing these giant planets to grow massive enough to capture hydrogen and helium, right? So the very same thing, right? So like sometimes this is a very, very common question in UPSC, IS and IFS is they will ask you to differentiate between terrestrial planets versus Jovian planets, right? So this is a very common question. So you can write a lot of points in them, right? So like in these handwritten notes, they are very clearly covered, right? So this terrestrial planet and Jovian planet, right? So this, firstly, see, everybody will be writing like this only. They will be making diagram and they will 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 12 points, right? If you will write 12 points in a 10 marker, you will get 8 marks, right? You will surely get 8 marks, right? But if you want to score 9 marks more than these people, what you can do is that you draw diagram, you draw this table itself, but you also give the reason for this difference, right? So you can use the knowledge which you have, even if they don't ask you about, they don't ask you about this four astronomical unit distance, frost line, all these things. But if you are able to use these keywords in this question, you will definitely get more marks than your competitor, right? So this is relatively a easier topic. This is a easier question, but if you are able to give reasoning to these why these differences are there, you will definitely get more marks, right? So like we often keep check copying like copying we check a lot of copies in test series, but we don't find these reasons. So that is the reason for relatively lesser marks. So the first thing, if you are asked about difference between these two, you can say these are the example of terrestrial, these are example of Jovian planets, right? So in terrestrial, their orbits are closer. Here, their orbits are farther apart. Their diameter is smaller. Their diameter is large. So you should know the reason. The diameter is smaller because they are composed of 0.7% of the material of the nebula, right? And they are composed of the 99% of the composition, right? They are more dense. Why they are dense? Because they are made up of silicates and all these things. So why they are made up of silicates and iron and silica? This terrestrial planet, because they come in this 4 astronomical unit zone, which is very warm for lighter element to survive, right? So that is why. So that is why they have thinner or no atmosphere. They have this atmosphere. They have rock surface. They have gases. They have hydrogen, helium, all these things, right? They are closer to sun. They are warmer. These are all commonsensical difference, right? They have few moons. They have higher moons. All these things you can write yourself, but do give the reasons, right? So this is directly there in your syllabus, right? So, and just last thing in this topic is, so I hope you can all do it. So the last thing is, sometimes they can ask you write a short note on nebular hypothesis, also pinpoint limitation in nebular hypothesis, right? So see, these are all still matter of research, and you can get a lot of literature on all these things, but for our purpose you have to be very brief, and you don't have to go in much in detail, right? You don't have to do PhD in these, right? So there are a lot of points. These are the two most important points which you will get in all the good books or even in research paper, right? The first thing is, a lot of scientists question that about the conservation of angular momentum even in nebular hypothesis, right? Like I said you about an experiment, like in your physics classes in your 8th and 9th standard, you must have heard about this, na? So like whenever a person is rotating, right, and if he or she bring her arms closer to her body, what will happen? Her angular velocity increases, right? This is a very common observation or an experiment. Her angular omega, it increases because her angular momentum needs to be conserved, right? So angular momentum is mvr, and so if r is decreasing, velocity has to increase, something like that, right? So basically, so what happened was, when the nebula was colliding, some scientists say that when the nebula was collapsing, what ultimately r is decreasing, so what should happen? The rotation velocity should increase. And actually the rotation velocity did increase as the nebula was collapsing. But when the scientists calculated, some of them argued that the increase in the rotation velocity is not as much which is expected, right? So the collapse of material to the center of rotating disk should have caused the sun to rotate faster than its current rotation speed, right? So that is the thing. So some scientists argue that this can be explained by the drag created by dust grains, right? So when there were a lot of grains here, when they were collapsing, there were also some kind of drag. So due to that drag, some kind of angular momentum was lost, right? So there were some technical things. You don't have to go in detail. You just say that this is one of the criticism, and which is explained by some scientists through drag of dust grain. That's it. The second point is about axial tilts, right? So what is axial tilt is that, according to nebular hypothesis, all planets around a star should be tilted in almost the same way, right? Related to ecliptic path. So like, what is ecliptic path? This is sun, and all the planets revolve around the sun in an ecliptic path, in an ellipse, right? So all these planets should have same axial tilt, right? They are rotating around an axis, right? So can anybody tell me what is the axial tilt of Earth? What is axial tilt of Earth? How much the axis is tilted around which the Earth is rotating? Yes, Danish is saying 23.5, right? So right, very good. So the actual tilt is 23.5. So the Earth and Mars, they have similar tilt, right? Earth is 23.5, 23.4, and Mars is around 25 degrees Celsius. But the outer planets, they have a tilt, right? Jupiter has a very low tilt of just 3 degree, right? Whereas Saturn and Neptune are around 25, 26 or 28 degrees. And Uranus is like extreme 97 degree tilt, right? It is more than 90 degrees, Uranus, right? So this is an observation, and this is a criticism of nebular hypothesis, right? But then a lot of scientists, they say that actually in the very initial stages the tilt was same, but this difference in the tilt is due to event which happened after the formation of solar system, right? Maybe this Uranus might have faced a very severe collision with another planet, or another meteorite or asteroid, right? And because of that, there is significant tilt in its axis, right? So this is explained by events that happened after the formation of solar system. So this is how this criticism of differential axial tilt is dealt by nebular hypothesis, right? So I hope you can answer this now. If they're asking you, if they can ask you even in interviews in civil services and in forest services, that what are the limitations of Nebular hypothesis. So you can say that one argument is related to angular momentum conservation, that the increase in the angular velocity is not as much as calculated by some scientists, and second one is there is differential in the axial tilt, and but there are also explanation. So that is the best fit model presently we have to explain the origin of solar system, right? So this is all about solar system, and again finally whatever we have read in last 1.5 hour, you can I'll share this, uh, handwritten notes with you. You just mug it up and it will these handwritten notes, right? You can just mug it up, you can make your own notes of these 3-4 pages and it will be done, right? So about these first page is about general origin of universe. So we know what happened about Big Bang, we have revised it also. Then these are 4 important points, right, which any theory should explain to be accepted about origin of solar system. So we have a lot of theories, tidal theories, Chamberlain theories. These both are biparental in origin, right? That there were not one but 2 stars initially, and when they interacted it led to distortion in the sun, and that distortion is nothing but the modern day planet, right? But these are discarded, right? The most accepted, most contemporary theory is SNDM, solar nebular disk model. At some places it is known as Nebular hypothesis, right? Something like that. So in this you can define what is the nebulae, you know it, and then you can just explain everything by this chart, right? Flow chart. So there was nebula, it start collapsing, then there is protostar and protoplanetary disk, then planetesimal, they form protoplanet, and we have the current state, right? And there are 2 limitations. One criticism is about conservation of angular momentum is not present as per some scientists, but then there are some explanation to that, and one is about axial tilt, which can also be explained by post formation events, right? Then there is some very common question on difference between terrestrial planet and Jovian planet. So there are these 12 points which are directly given here. You can write them, you can add your own, plus it would be best if you can give reasons to them also, at least for the starting 3-4. You will get 9 out of 10 marks in this question, right? This is a very common repeated question, right? So this is what you can cover in origin of solar system. So in the next class we will start with meteorite, which is the most important topic of this unit, right? And then we will move ahead, right? So I think we can end the class here. If you have any doubt, you can ask. Anybody, any doubts? See, this is not very comfortable topic for a lot of accretion. Accretion is nothing. It is a technical term which you should cautiously asking what is accretion. So accretion is basically coming together and to form clumps, right? Suppose this is a small planet, this is a small body, this is small body, this is small body. So they are coming together under the effect of gravity. They are coming together under the effect of gravity, right? Due to gravitational pull, and then these both are becoming bigger one, right? This is accretion, nothing, right? So this is just a technical term which is used, and you should use it in exam also, right? So we used various terms, accretion, we used collisions, right? We use bombardment. So these are all technical jargon which you can score. Sir, notes will be available in the Telegram group. So Shiv, notes will be available on the portal, right? So we have given you access. You just log into website and you will get all these notes on the portal itself, right? It will not be available in Telegram group. In the private Telegram group, we share about the updates about the classes, all these things, but notes are available on the portal, right? Under this general geology. And this video is also uploaded, is also recorded, and it will be uploaded within a couple of hours, right? So okay, we'll meet tomorrow. I hope you learned something about origin of solar system today, and we'll move on to meteorites and other important topics of general geology syllabus, right? So I'll end the class here. If you have any doubts, you can also ask in the next class, right? So thank you.